years ago, on July 15, 2004, NASA launched a new science satellite, Aura. The third in NASA's Earth-observing system of satellites, Aura was designed to monitor the composition of the Earth's atmosphere and record our planet's health. Aura measures the crucial gases that affect our protective ozone layer, the quality of the air we breathe, and our changing climate. The region of our upper atmosphere known as the ozone layer protects everyone living on Earth's surface.
Ozone screens ultraviolet radiation. If there's less ozone, you sunburn faster. This UV radiation can also cause things like skin cancer. It can result in the suppression of your immune system.
A few decades ago, man-made chemical substances known as CFCs were destroying our ozone layer.
Ozone-depleting substances were going up and up and up during the 1970s. In 1987, the Montreal Protocol was signed, and that slowed the growth rate. And in fact, now, every nation on the Earth has signed the Montreal Protocol, and these ozone-depleting substances are fully banned. So we needed a satellite to go up that could watch the ozone layer and see how these man-made chemicals were impacting ozone. So this is really a key period. Is ozone starting to recover from the effects of these ozone-depleting substances? Ozone was going down, and now it's kind of gone flat. And Aura has been flying during this period, telling us exactly what's happening to ozone. And we're hoping that in the next decade or so, we're going to see ozone start going up.
Aura also measures the pollutant gases in our lower atmosphere, near the surface.
We've seen dramatic changes in the U.S. air pollution during the Aura record since 2004. Our air quality is improving. It's a lot better than it was a decade ago, and that has been the result of environmental regulations. They're working.
Even though air quality has been improving in the U.S., other places in the world have seen their air quality get worse.
In countries like China and India and many other countries in the Middle East to Africa, we're seeing pollutant emissions go up. And so satellites are able to see their pollutant levels and monitor them over time.
Aura also measures aerosols and gases such as carbon dioxide, methane, and water vapor, so that scientists can study how they interact with clouds and each other, affecting our climate.
If you want to understand climate change, you need to monitor the greenhouse gases and how they change over time.
Climate change takes decades, and it certainly takes more than 10 years to study and understand it. Aura's record of greenhouse gases and aerosols adds to the satellite and ground data that we've accumulated over the past several decades. Along with measurements of things like clouds and rainfall from other satellites, Aura composition data reveal the processes that contribute to climate change.
Aura has 4 instruments. The first one is the ozone monitoring instrument. The second one is TESS. It measures in the infrared, and it measures things like carbon monoxide. The third instrument is the microwave limb sounder. MLS measures a range of gases. Chlorine monoxide also measures ozone. And the fourth instrument is HRDLS. It didn't last very long, but HRDLS could measure, again, ozone. It could measure some of the chlorofluorocarbons. Some of these instruments had evolved from earlier instruments, but Aura brought new technology and better resolution.
Over these past 10 years, Aura has been here to witness and record this momentous time in our environmental history. Aura sees the effects of emission regulations on our ozone layer and our air quality, and monitors the greenhouse gases that contribute to our changing climate. The Aura mission was designed to last 5 years. We are now celebrating the mission's 10-year anniversary, and its instruments are still producing excellent science data. Based on the amount of fuel left in the spacecraft and the condition of the instruments, engineers project that Aura will continue delivering crucial science data until 2022 and beyond.